Hey everyone, welcome to Insights by Rish. Today we are going to implement spam message detection project, and for that we have this particular dataset which consists of just two columns, SMS and the label. The label falls into two categories, 0 and 1. 0 are your regular SMS, the normal ones, while the 1 are your spam SMS. The spam SMS basically means the unwanted, or you can say the marketing sponsored emails or the messages that are just bombarded onto your system. So here we have the data of SMS, and you want to classify whether the SMS is spam or ham. Now, whenever you receive the spam email, then your Gmail application automatically puts that spam email into the spam section. This is because this Gmail account extracts some particular words from that email, and it tries to classify whether that words fall into the spam section or ham section. It matches with the words that previously fall into the spam and ham section, and according to that, on the basis of that, it converts whether the currently received email is a spam or ham, and according to that, it puts your email into the spam section. And that is what we are going to do here as well. So this is the particular dataset. I will provide the dataset in the description box. Do check that. Now, starting here, I have loaded the spam SMS CSV file into my Google Colab folder into this environment, and first we'll start by importing necessary libraries. Now we can perform this. This is a natural language processing project, and we can perform this using the NLTK library, which is the natural language toolkit, and also using the Spacy library. Here in this project, we are going to prefer Spacy library because that's more efficient than the NLTK library. So let's start by importing Spacy library. So import Spacy. The next thing that we want to do here, we need to build the Spacy pipeline, and you can build your pipeline into any variable. I will name that variable as NLP, which is natural language processing, and I will say Spacy.load. I will provide the pipeline. I will import the English module. The Spacy provides you with the various language modules, and here I will import the English one, which is en_core_web and sm for small. So this is our NLP pipeline, the Spacy pipeline, and let me run this. Now that we have imported the pipeline as well, we will import the dataset which is loaded into the Google Colab environment. For that, we require pandas library, so we will import that first. And after that, we will load our dataset into the df variable. So we'll say pd.readcsv, and I will provide the path for this particular file. We don't require this content here. Now let's run this. Let us try to display first 5 rows of the data frame. So this is our dataset, the SMS column and the label column. Now the first thing that we want to do, we need to either perform stemming or lemmatization onto this SMS column. Basically both are same, but there's a thin difference between both of them, and the thin difference is that the stemming doesn't consider the context of the data, while the lemmatization does. Also, the difference is that the Spacy doesn't provide any support for stemming, and hence if you want to perform stemming, you prefer NLTK library, and there you need to first tokenize the words. By tokenize, what I mean, breaking the whole statement into the individual words. First, you need to explicitly tokenize the words and then convert them into their stem words, or you can say the base words. While when you prefer lemmatization using the Spacy library, you don't need to explicitly tokenize the words. The lemmatization and the Spacy library will do it for you in background. Now, what we mean by lemmatization here is on Google, I have got this image from Bot Penguin, and here you can see there are various words which maps to a same common base word. The changing, changed, and change. All these 3 words basically has the same meaning. If you remove their suffix and some prefix, they all maps to a same common single base word, which is change. So this base word is called as lemma, and now as you are converting your words into this lemma, this process is called as lemmatization. So the first process that we want to perform here into our model, we need to convert this SMS column into lemma. That is, we need to convert the words from every SMS to their base words, and to do so, we'll start by writing a function. So we'll write a function as def lemmatization Here we will pass a text. The text will basically be an individual SMS from the SMS column, and here we'll say doc is equal to NLP on text. Whatever SMS we are receiving into our text variable, we are passing that to our NLP spacey pipeline. NLP is the variable into which we have loaded our pipeline, and we are passing every text received from the SMS column to this spacey pipeline. The next thing is we will write a list comprehension here. So we'll write lemma list, and here we will say token dot lemma for token in doc. So this is a list comprehension code snippet. Here what you are saying, the text that you are receiving from this SMS column, let's say you are receiving the first SMS present on the index 0. In that case, the whole SMS from the index 0 will pass to this text, which will be then passed to the NLP pipeline. And when you pass that text to this particular list comprehension, it will extract individual words and convert them into their base words. That's what we are doing here. And when you just do this much, then in that case, you in your result you get all those base words row by row and not in a single line. But here, as you want to store the base words for every SMS in a single row, you need to perform join on this list. So you need to return dot you're joining on the basis of space. Wherever you find white space, on that basis you will join the word. So you will say join your lemma list. So this is the function that we wrote. Let's run this. Now we will apply this function on our SMS column. First, we will create a new column named as lemma, and here we will say we will apply the function on the SMS column from the data frame DF. So we will write apply lemmatization function. Let's run this. Now let us try to display the first 5 rows of our data frame. So we will use the head function here. And now we will encounter a new added column, which is lemma. It stores the base words for every SMS. As you can see here, if I want to show you an example, you can see on the index 1, the joking word is converted into joke. The suffix ing is removed. In same way, on the index 4, you can see the don't is converted to do not. The lives is converted to live. So in this way you perform lemmatization. Now this lemmatization is free of error. If you would have performed stemming here, in that case you would have encountered many errors and misspellings here. Now that we have performed lemmatization, the next task that we want to do here is we need to remove the stop words. Now what do we mean by stop words? Again I will take you to Google, and here we have this image from Computer Hope, and you can see here the red words are your stop words, while the black words are your normal words. Now what do we mean by stop words? When we divide our sentence into individual words, the words that individually don't mean anything or do not provide any context, do not provide any meaning individually, that words are known as stop words. If you divide this first sentence, when was the first computer invented? When you divide this sentence into words, individual words, you can see the single word computer means something, while the invented word also provides some context, some meaning. The first word also provides some context and meaning. But if you take the word was, it doesn't provide you with any meaning that you can extract whenever you occur with this word. Or you can say the from this individual word you don't understand any meaning. When you encounter the single word computer, you can say that the document is about something technology, or some technical document is there, because we are having the high frequency for the word computer in this particular document. But when you have the let's say the word when into your document, that individual word doesn't provide any context here. So the words that in individual doesn't provide any meaning, such words are known as stop words, and it's very necessary to eliminate such words from our data in order to make the model more efficient. So the next thing that we want to do here, we will perform the remove stop words function on this lemma column, and we will only include the words that will provide meanings in individual, and we will remove all the stop words. Also we will remove if there are any punctuations here. So we'll again write a function for that. and let us name that function as a def remove stop words. So remove stop words. Here again we will pass the text. Now the text will be the every row of lemma column. It's a text. Next thing that we want to do here, again we will say doc is equal to NLP on the text. That is, every time you receive a single instance from the lemma column, you put that into your spacey pipeline. Now we will write again a list comprehension code snippet. So we'll write no stop words is equal to, we will say word dot, or you can say token dot text for token in doc. But we also need to provide a condition that what we are doing here basically means we are extracting every instance from the lemma column, then we are putting that instance into the spacey pipeline, and then we are going to extract the text. But we need to provide a condition here such that the text shouldn't be a stop word or a punctuation, and for that we'll write if not token dot is stop. Now this is stop are the inbuilt methods, or you can say the inbuilt functions, and not token dot is punct. So this is our syntax for the list comprehension. We are saying that we want to extract every text from the every instance of lemma column such that the text shouldn't be a stop word, that is if not token dot is stop, and the text also shouldn't be a punctuation. And next again we will join it, as we want everything in a single row. So written, we'll join it on the space dot join, and we'll provide no stop words here. Let's run this function, and now we'll apply this function onto our lemma column. So we will first create a new column here, which is let us name this as pre-processed. So we have pre-processed the data, so we'll create a new column pre-processed, and then we will apply the remove stop word function onto the lemma column. Let me copy this function. We'll apply that function onto the lemma column. Now that we have pre-processed our data, let us again display the first 5 rows of our data frame. We will encounter a new column here which is pre-processed. Now this pre-processed column stores all the pre-processed data. That is, now we don't have any stop words, we don't have any punctuations, and also we have converted all the words to their base words. So now the next thing that we will do, first we will divide the whole data set into our input data frame and into our target feature. So here our input is the pre-processed column, and our target is the label that we want to predict whether the message is spam or ham. So we will divide accordingly. We'll say the input data will be stored in the x variable. So here we will say df, and the column which we want to pass as an input is the pre-processed column, and the y, here we will store our target feature which is label. Let's run this. Now that we have divided our dataset into the input and target feature, next we will perform train test split, that we want to divide our dataset into the training set and the testing set. So for that we will import train test split from sklearn library. So from sklearn.preprocessing, sklearn.model selection, we will import train test split. Now we will say xtrain, xtest, ytrain, ytest is equal to train test split, and we'll pass our x data frame and the y, and the test size will be 0.2, which means 80% data in the training set and 20% data in the testing set, and we will also provide random state is equal to true. And we will also provide random state is equal to 42. You can provide any number here. This basically means that we want same data in our training and testing set every time when we rerun this code. Now let's run this cell. Let us check the shape. So xtrain.shape and xtest.shape. So 4459 rows are in the training set and 1115 rows are in the testing set. Now one thing you can notice here, the data set or you can say the training and the testing set are in the form of series data structure and not in the form of data frame data structure. This is because I will tell you the reason why we have preferred the series data frame while loading here in the X and Y data set. We haven't preferred the input feature as the data frame. If you try to check the data type here, let's say type of X. You can see the type is series and not a data frame. Now that we have divided our model into the training and testing set, we will start building our model. Now to do so, we will use the random forest classifier algorithm to perform the spam message detection. You can also perform the same thing using the naive Bayes algorithm as well. You can prefer the multinomial naive Bayes or Gaussian naive Bayes, but from the trial and error basis, when I tried to evaluate the model using different algorithms using the grid search CV, I found that random forest classifier gives best accuracy compared to all other algorithms, and hence I have preferred the random forest classifier. So from sklearn.ensemble, you will import random forest classifier. We will also import the pipeline we will use to build our model. So from sklearn.pipeline, we will import the pipeline. And then we will import TF-IDF vectorizer from the feature extraction of sklearn, and I will let you know what we mean by TF-IDF vectorizer. So let us import it first. So sklearn.feature, you will get some feature extraction .text. You import TF-IDF vectorizer here. Let us run this and we'll try to understand what is TF-IDF vectorizer here. So on the Google, from the medium, I have got this image of TF-IDF vectorizer here. Let us try to understand what this image means. When you look at the image, the trainx consists of your training set. Here you have two documents. The first green document is this is good and awesome, and the second document is this is bad. Now here you can see you have two columns here into this square, into the blue square. You have two columns. You can see two set. The first set is of term frequency and the second set is of inverse document frequency. The term frequency basically means the number of time your word appears into your document and divided by total number of terms into that document. When you check this first set, you can see the document is divided into words. This is good, bad, awesome, and. So it consists of words from all documents that are provided in the training set. Now you can see that this word is appeared only once in the first document, and the first document consists of total 5 words. So the frequency of this is 1 divided by 5. Same for is, same for good. Now the bad word isn't present in the first document, so the frequency is 0, and same goes for awesome and. Next, when you check for the second document, this is bad. Here you can see the word this is appeared once, while the document consists of 3 words, this, is, and bad. So the frequency for this for the second document is 1 divided by 3. Same for is and same for bad. While the good, awesome, and word aren't present in the second document, hence the frequency is 0. So this is term frequency. You take the frequency of that particular word into that particular document divided by the total words present in that particular document. That's your term frequency. And the second set, the bottom set you can see, is for inverse document frequency. Here you take log of the ratio of documents that include the word. What you basically do, you on your numerator you have how many documents you have in your training set, and on the denominator side you have how many times the word has been included into that document. So when you check for this and you apply log onto that, so when you check for the word this, now total documents that you have are two. The first document is this is good and awesome, and the second document is this is bad. So you have two documents. Hence in your numerator you will have value 2, and this, the word this, is present in both the documents. Hence the frequency for this is log of 2 divided by 2. Same for is. When you check the word good, the total number of documents you have in your training set are 2. Hence on the numerator you have 2, and the good word is only present in a single document. Hence on the denominator side you have 1, and you take the log of that. So this is the inverse document frequency, where on your numerator side you have the total number of documents that you have, and on the denominator side you have the number of documents into which you have occurred that word. So these are the term frequency and the inverse document frequency, and when you multiply this both term frequency into inverse document frequency, you get TF-IDF vectorizer. So TF-IDF vectorizer, formula for TF-IDF is term frequency into inverse document frequency. So when you check for the word this, so first the log of 2 by 2, 2 by 2 is 0, log of 0 is 0. Hence when you multiply both 1 divided by 5 and 1 divided by 3 from this column of term frequency, you get 0 because you are multiplying it with the log of 0. So hence you can see in the features set on the right side, both the values for this is 0. Same goes for is. When you take the look at good column, your inverse document frequency for good is log of 2 divided by 1. And when you multiply it by 1 divided by 5 from your term frequency with log of 2 divided by 1, that's stored in the good column of document 1. That's your TF-IDF for good of document 1. And the second value for good in the term frequency is 0, and hence when you multiply it by log you get 0. So this is how the TF-IDF vectorizer works, and it's good because here what you want to do, you want to lower the influence of unwanted words and increase the influence of necessary words. So that is what we are going to perform using the TF-IDF vectorizer here. So we'll build a pipeline and let us name it as model. So model is equal to, we will say pipeline, the pipeline that we have imported from sklearn, and then we will say the first thing that we want here is vectorizer. So vectorizer underscore the TF-IDF vectorizer, the term frequency inverse document frequency, that's the full form for TF-IDF. And here you will provide with TF-IDF vectorizer. Now as this is a function, you will also provide it with a parenthesis. Next thing, after TF-IDF vectorizer, you are going to use the random forest classifier to classify the messages. You are using random forest classifier algorithm of machine learning, and hence you will say here random forest comma random forest classifier. Again, this is a function, so you will provide it with an parenthesis. That's it. The next thing that you want to do, you will fit the training set. So model.fit xtrain and ytrain. Let's run this. Now you have fitted your model. You have got your TF-IDF vectorizer and your random forest classifier as well. The next thing that we will do, we will try to check the accuracy here. So to check the accuracy, we will say model.score. You will evaluate your model on the testing set. So xtest comma ytest, and you want your accuracy to be displayed in the form of percentage. Hence you will multiply it by 100. So you can see the model is giving 97% accuracy, which is quite good. So this is how you evaluate your model on the testing set, and this is how you build your model using the pipeline and TF-IDF vectorizer. If you want to make some predictions, you can do something like this. You can say model.predict for xtest, and these are your values. So firstly, we'll store all these predicted values in the variable pred. and first we will check the true labels. So let's say we want to check the true labels for the first 5 SMS, that is whether the messages are spam or ham. When you check the first 5 labels, they all are 0, which means all the 5 messages, the first 5 messages from the testing set are regular ham messages. And let's check what our model has to say about the same. So let us say the first 5 labels from the predicted ones. So our model has also predicted the first 5 test messages from the testing set as regular ham messages. So the model is correctly classifying the things. If you want, you can also print the classification report. So from sklearn.metrics, you import the classification report and the confusion matrix. Let us try to print the classification report. So we will say classification report, and here you will pass your true data, which is stored in y-test, and your predicted data, which is stored in pred variable. Let us display this. And this is your classification report. You can see the F1 score for both the classes 0 and 1 are greater than 90, which means the data set is not imbalanced. The data set is balanced. If you find the difference between your F1 score of both the categories is very huge, then in that case you can say that your data set is imbalanced and you need to take some measures in order to balance that. Here our data set is balanced, which is giving us 98% accuracy. The precision is also good. And precision is 1, that is the 100% for the spam messages, that is for the category 1. So this was these are all the conclusions that you can draw after looking at your classification report. And the last thing that we will do here, we will plot the confusion matrix. And to plot the confusion matrix, first we will import cbun, cbun as SNS, and we'll also set the background for that. So SNS dot set style dark grid. Now we will say CF, which is your confusion matrix variable. Into this you will say confusion matrix, and you will provide the true labels which are stored in y-test and the predicted labels which are stored in pred variable. You will also provide one more attribute as normalize is equal to true, because you want to check your confusion matrix with the values displayed in a percentage format and not in a decimal, or you can say the raised to format. And next we will plot the heat map. So SNS dot heat map, you will pass that CF variable. You will say N0 is equal to true, which means you want to display the values on the grid. And the C map, the theme of your heat map should be, let's say, green. Let's run this, and you can see this is your heat map. So when you take a look at your diagonal values, the diagonal values, that is the first diagonal which is showing you 1, which means 100%. That is 100% time it's happening that the message is regular, that is the label on your y-axis stands for actual label and on your x-axis stands for predicted label. So you can see 100% time, that is every time the regular messages are correctly getting classified into your regular messages, while 86% times the spam messages are getting classified correctly. Only 14% times it's happening that the message is spam, but the model is classifying it as a regular one. So this was the confusion matrix, and this was the model that we built for detecting the spam messages. That's it for the video. Thanks for watching.